yesterday regarding particle motion? What kind of motion are we talking about?
Yeah, if number one is number two.
Okay, we'll talk about that tomorrow. Stop discussing the quiz. Super Saturday, okay? Alright. So, yesterday we talked about particle motion, rectilinear motion for the calculus test. Right? Every now and then you will throw something regarding vertical motion, but the majority of the time it's rectilinear, left or right. This will be one question on the AP test for the free response. So you do have to make sure you understand particle motion. Right? Sounds good? We talked about two different rates of change yesterday. Right? What was the first derivative of the position? Velocity, right? And what was the first derivative of velocity? Acceleration, right? We know that velocity is a rate of change. It not only gives us magnitude, but it gives us what? Direction, right? So it not only tells us the rate at which the position is changing, but it also tells us the what? The direction that it's moving, right? So if the velocity were to be positive, that means that the particle would be moving to the right at some particular rate, right? If I say I'm going negative 75 miles per hour, that's my velocity. That means I'm going to the left at a rate of 75 miles per hour. Okay? If I ask for average rate of change or average velocity, that would be the average rate of change of what? If I look for average velocity, that's the average rate of change of who? Of the position. That's why I have to use the position function there to figure it out, right? If I look for instantaneous velocity, that's the instantaneous rate of change of position, or the first derivative of it. Yes? Good? Alright. So we went over this stuff, we went over the relations, we talked about all that good stuff. Let's do some examples. See if you guys filled them in last night. Maybe some of you forgot to do it. It shouldn't be too hard, right? So looking at this, it says, at which point is the velocity equal to 0? What kind of graph is this? Which is the one that they're giving us? The position, right? So this is S of t, the position graph. Not a very good one, but we'll use it. Okay? So, can time be negative? No, right? So, for our sake, we're going to consider this graph to represent a particle moving over time, and obviously the time has to start at what? At 0. Okay? Good? Alright, so it says, at which points is the velocity equal to 0? What would that imply if I'm looking for the velocity in relation to the position graph? So for the velocity to equal to 0, it means that S prime of t has to equal to 0. Right? The first derivative of this. So I have to imagine tangent lines on this graph because I'm talking about the next derivative, right? And I'm looking for where those tangent lines have a slope of 0. Or where I would have horizontal tangent lines, right? So where would that happen? Okay, so v of t is equal to 0 means that S prime of t equals 0, which occurs at B and D, because, what can you tell me regarding S of t? Because you got to justify it based off of this graph. Very good, because S of t has relative. Could we also say because S of t has what? What if it didn't have a relative extrema and I was still able to find the velocity equal to 0? It would be a horizontal what? Tangent. So would it be better for us to say relative extrema or horizontal tangent? In this case, could we say relative extrema? Yes, because it is true. Those are the only places where I have it. Right? But if I had a different graph, I want to be careful. Because I could have a horizontal tangent somewhere. The velocity would equal to 0. Good? Alright. At which points does the acceleration equal to 0? Let's acceleration. So that's a of t. If a of t is equal to 0, what does that mean? That means s double prime of t, which is the second derivative of the position function, has to equal to 0. And what does it mean when the second derivative equals to 0? Or how do I know a specific place where the second derivative equals to 0? At a point of inflection, right? So, is there a point of inflection here? Okay? So this occurs at C because S of t has a point of inflection. What happens at a point of inflection? It changes concave. Good? On what intervals is the particle's velocity positive?
When it's increasing?
Okay, so that's the because, but you haven't told me the interval. So the velocity has to be positive, so that means v of t has to be greater than 0, right? That means that s prime of t has to be greater than 0, right? And that occurs where? When the first derivative is positive out of it, what does that mean about the original function? It's increasing, right? So like they said, the position function had to be increasing. So we only want to say from A to B?
And D.
Because we don't know specifically where this guy starts, right? But it is increasing over here beyond A, but since there's no point there defined, we're not going to say. We don't want to say from 0 this way, right? No? Okay. So we'll say specifically where?
A to B and D.
A to B? In union with?
D.
For that one, do I have to say only from D to E, or for that one, could I say from D to infinity?
Well, I mean, it could go down.
Yeah, you
Could it
never
go
know.
down?
Yeah, you never know whether it can go down again.
You never know?
Unless they say that it's like on a closed interval.
Right.
Then
Only the velocity.
yeah, like
So you don't want to go to infinity? You only want to go up to E?
Yeah.
Okay. So only from D to E? Because? What's my because statement? S of t is increased. You have to justify using that function. Alright, on what intervals is the particle's velocity negative? The velocity has to be less than 0. That means that the first derivative of the position has to be less than 0. And if my first derivative of anything is negative, that means my original function has to be what?
decreasing.
Decreasing. So where is this curve decreasing?
B to D.
From B to D, right? Okay, and that's because we already know it, right? S of t is decreasing. So we understand what's happening. Right. On what intervals is the particle's acceleration positive?
Where the concavity is.
So acceleration has to be greater than 0. That means the second derivative of the position has to be greater than 0. So if my second derivative is positive, how do I know where the second derivative is positive? The original function has to be concave up, right? So where is this function concave up?
From C to E.
From where?
C to E.
C to E?
They mark it wrong.
Would the mark it wrong if we put to infinity? No. It would be correct. Okay? So on C to E, because
S of T is concave up.
S of t is concave. Very good. And the last one, how would I know where my acceleration is negative?
It's concave. Yeah, it's concave then.
So a of t is less than 0 means the second derivative is less than 0. And we know that's going to be where the function is concave down. Where would that occur?
B to C.
A to C? Okay. Because S of t is concave down. Too easy? Yes?
Yeah.
Easier than the test?
Quiz.
Oh, the quiz. Alright,
That's
so
fifth grade.
let's see how many of these commandments we can write. See? We're actually gonna write 6.
And you said it yourself.
Okay, not 5. Maybe we'll get them to be up to 10.
And you said it.
I don't know. So, a couple of commandments, a couple of very important things to remember regarding particle motion. And again, remember that it's particle motion along the what axis? The x-axis, okay? We're talking about particle motion along the x-axis. What did we say it meant if the velocity is positive? What did that mean for my position, for my particle? So the particle moves to the right. So that's one of the things that they'll ask on the AP test. Find the intervals where the particle is moving to the right. Find the intervals where the particle is moving to the left. Find the places or the times at which the particle is at rest. Find the times at which the particle changed direction. Okay? So in order to find all those, you have to know the velocity, right? Now they might give you the velocity graph to look at. They might give you the original function. They might give you the original function's graph. We don't know. Okay? They'll give you different things depending on what they give you is what you need to do. Good? Alright, what's the second one? If velocity is negative. What do we know about the particle's position?
Moves to the left.
Very good. The particle moves to the left. So here the first derivative of the position would have to be positive. Here the first derivative would have to be negative. Easy? Alright. What if I said the velocity was 0? What would that mean?
That means it's staying.
It's not moving?
Yeah.
So that means that the particle is at rest? It could be momentarily, right? Could be for like a split second. And then what would happen?
It changes direction.
Could change direction, right? Or it could accelerate in the same direction, right?
Yeah.
Okay. So could acceleration be positive or negative and velocity be 0?
Less than.
Yes? Could velocity be 0 but acceleration not be 0?
You're just changing all.
Yes? It would be like momentarily, right? Like I stopped and then I press the pedal again, right? I accelerated. Yeah, like a jerk. A jerk is like where you're already driving and then you press the pedal.
Yeah.
Yeah?
You like that?
Cool? Do I have to stop there already? Oh, shucks. Alright. Well, have a good weekend, okay? Don't party too much.
After this quiz. Your acceleration changes.